Hi, this video is about phase changes. We've been talking about heat transfer, and mostly we've been talking about the heat transfer due to change in temperature, so Q equals mc delta T. But that's just changes in temperature. That doesn't account for things like melting, or freezing, or boiling, evaporating. So today we're talking about those things. And you know a bunch of this already. What are phase changes? It's where one state of matter changes to another, solid, liquid, gas. And so we've got boiling or evaporating. We boil away some water, turns to steam. And the opposite of that, where we have water vapor that condenses into liquid water. So evaporation and condensation, we've got those. We can have water freezing into ice cubes, or we can have ice cubes melting into liquid water. So here's liquid to gas, here's liquid to solid. Is there such a thing as something transitioning from gas to solid? Absolutely. And when something goes straight from a solid to a gas, it's called sublimation, and you probably have experienced this if you've ever seen dry ice. Dry ice doesn't go through a liquid phase, it's solid, and then it just goes straight to the gas. It's called sublimation. How about the opposite? Can a gas go straight to a solid? And again, you're familiar with this if you've lived in Wisconsin through a winter. You go out to your car and you say, crap, I gotta scrape the frost off. That frost is a process of water vapor in the air going directly into the solid phase. And that's called deposition. So we've got these phase changes. And if you think about it, these phase changes have to take heat to make them work. They either absorb heat, so like melt an ice cube, the ice cube has to absorb heat, or to freeze something, you have to take heat away from it. How much heat does that take? And so the process of figuring out how much heat it takes to melt or freeze or boil or condense or blah, 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 it depends on the mass, like we have with mc delta T, and it also depends on a latent heat. And capital L is what we say for that. And there's two of them, the two that we're going to focus on here for melting and evaporation. And one of them is the latent heat of fusion. And how do you remember what that means? Well, I think of something fusing together, coming together into a whole. That is where we have something freezing. So fusion, the latent heat of fusion, is this process, freezing or melting. It's the amount of heat, the amount of calories or joules it takes to change from a liquid to a solid state, depending upon how much mass there is. And now we have the latent heat of vaporization. Vapor is a gas. Also, I think about in terms of evaporate. And so I think of evaporate, vapor. This is the transition between liquid and gas. And you can look up the values for this for the different materials. We're mostly going to be working with water. It's the most interesting to us because we deal with that one so much. Everybody uses ice cubes. You know, you use them in the summer, you use them in your coolers and your drinks, and we know what happens to ice cubes. They melt. So that's kind of fun. So here we have the basic process, the basic equation for how to figure out the amount of heat it takes to melt something, freeze, boil, condense, all of that good stuff. So let's give it a try. Let's do a practice problem. Okay, so the problem we're going to look at, how much heat does it take to change an ice cube that starts out at minus 8 degrees C into water at 18 degrees C? So minus 8 degrees C, that's what, 5 or 10 degrees Fahrenheit, and 18 degrees C is about 65 degrees Fahrenheit, around that, just so you have a sense of what those are. Oh, and the ice cube has a mass of 40 grams. Okay, so we have an ice cube, and it's 40 grams, and it starts out at minus 8 degrees C, and then we're going to melt it into water at 18 degrees C. How much heat does it take to do this? That's the total heat required. So with phase changes, you have to think about how many different processes are actually going on. We don't go straight into the melting because we're not at melting temperature. So there's actually 3 processes here. The first process is we have to heat the ice up to the melting point. So heat ice to 0 degrees C. That'll be our first step. The second step will be to actually melt the ice into water. So make the water. And then the third, again, that water's going to be at 0 degrees. We need to heat the water up to 18. So heat the water up to 18 degrees C. So there are actually 3 processes involved here. Now one of them is this, it's going to involve this, again, latent heat of, is it fusion or vaporization? Well, are we dealing with vapor? No, we're dealing with the solid liquid. This is going to be fusion. So for this one, we're going to use Q equals mL fusion. Ooh, can't see that. How about this? Q equals mL fusion. Here we've got our standard MC delta T. Oh, my marker's dying. Here we've got our standard MC delta T. So we've got 3 ways to calculate the heat. We've got to heat the ice up, we've got to melt the ice, and then we've got to heat the melted ice, the water. Okay, so let's give it a try. Q1, MC delta T. What's the mass of the ice? That was 40. Ooh, all my markers are bad. What is the specific heat of ice? Well, that is half, 0.5 of gram degrees C. And then the change in temperature. We're starting at negative 8, excuse me, and we're ending at 0. So final minus initial. Okay, we got all the numbers, we can do the calculation, and I get 160 calories. 20 times, yep, okay. 160 calories. Whoop, I'm going off the edge here. Q2. The mass of the ice is 40 grams. I'm going to try one more color here, see if I can actually get some good markers. The mass of the ice is 40 grams, and we need to look up the latent heat of fusion. So what is the kind of heat variable? I don't know what to call it. To get water to ice or ice to water. Well, in this case, it is 79.7. Gotta remember that, 79.7 calories per gram. Oh, this still isn't a good marker. 3188 calories. Okay, we're going back to the green. I'm hoping that one works. Q3. Heat the water to 18 degrees C. Q equals MC delta T. The mass is still 40. Just because it changed state, it doesn't mean we lost any mass. There's still 40 grams of this stuff. C, now we're into water, so we've got our nice 1 gram degrees C, and then delta T. We end at 18, and we didn't start at minus 8. This is the water part. We started at 0. So if we do that, we get 720 calories. Now we can just add up the total heat. So we've got 160, 3188, and 722. The total heat required to take an ice cube at negative 8 degrees C, melt it, turn it, and then heat the water to 18 degrees C is 4068 calories. So that is the answer there. So that's just a general process that we're going to be taking if there's a phase change involved. You got to figure out, okay, I got to heat it to the phase change point, the boiling temperature or the freezing temperature. And then I've got to do the phase change, and then I'm probably going to have another temperature change, so there's going to be more heat involved there. So that's just a basic introduction to how to deal with phase changes. And really it's about this M times L. It's the mass involved times the latent heat, either of fusion or of vaporization. So there's our basic intro to phase change. Hope this was helpful.